Hey, math fans, welcome to section 4.3. Let's get started. So this section is really quick. In fact, one of the sections is even optional. We're going to be describing the scope of inference that is appropriate, and we're going to evaluate whether a statistical study has been carried out in an ethical manner. Every researcher needs to ask this question. Are we trying to do a study where we're trying to generalize something to a population, the results to a population, or are we trying to establish cause and effect? One of the first things we talked about was volunteers. And volunteers, when you're trying to generalize to a population, is bad. Volunteers bad for generalizing to a population. However, when we're trying to show cause and effect, and especially with experiments involving people, volunteers are okay, because usually that's all you have to go off of. It's usually people in a medical study who have high cholesterol or high blood pressure, and they're trying out a new drug. You can't randomly sample from the population. You usually get volunteers, and that's okay. That's okay, because we're not trying to generalize to a population in an experiment, okay? So the left-hand side here is sampling, and the right-hand side is experiments. Remember, with sampling, we have different forms of sampling, like the simple random sample, stratified, cluster, systematic, all designed to try and get results that can be generalized to a population. And remember also, we try to avoid the convenient sampling. Now remember, with experiments, we have different types of ways that we organize the treatments. One is called completely randomized, and the other one is called a randomized block, which is very close to what stratification is, yet it's trying to achieve a different thing. It's not, we're not trying to generalize to a population in experiments. We use blocking in experiments to lower the variability of our results. And then there's the special type of randomized block, which is called the matched pairs, and that's where you're actually pairing up results, like, for example, the two fastest runners, or two tomato plants that are getting, one's getting one type of fertilizer and the other one's getting another type of fertilizer. You match them up, but give them separate treatments, again, due to randomness, okay? So that's the big theme over here. Random is still a part of it. All the sampling is random, but here it's the random assignment of treatment that really shows the cause and effect relationship. But all of these sampling techniques also have to use randomness, so there's no bias when you're trying to generalize. But again, it's a different outcome. You have to keep in mind what you're trying to do in your study. So let's ask ourselves these questions. Were the individuals randomly assigned to groups? Were the individuals randomly selected? Okay, you're showing two different things. If they were randomly assigned to groups, you can show cause and effect. If they were randomly selected, you can generalize to the population. So here's a nice little graphic that kind of outlines this. Go ahead, this is in your book too, but go ahead and pause the video so you can kind of read about the inference that you can make. Can you make an inference about the population? It'd be wonderful if in an experiment you actually had people that were randomly selected and they were randomly assigned treatment. Then you could make an inference about the population and about cause and effect. Okay, but most of the time, you're going to be here or here, depending on whether or not you're doing a study to generalize to the population or a cause and effect. And we don't want to ever be here. Okay? In science and in statistics, we could have these well-designed experiments and they can show us only so much, but there becomes a point where we can't really establish causation for a number of different reasons, and a lot of them being ethical. Take a look at some of these cases down here. Does texting while driving increase the risk of having an accident? And we could do an experiment, but that would risk somebody's life, getting into an accident and potentially killing themselves. So are we going to carry out an experiment to see if there's a relationship between those two, a cause and effect relationship? The answer is no. We're going to have to leave a lot of those things just as observational studies, through surveys and what have you, asking people, were you texting when you had your accident? Same with does smoking cause lung cancer? We can't really lock people up in a room and force them to smoke cigarettes until they get lung cancer to show a cause and effect relationship. So there is a boundary in which we can only ascertain so much information. So when we can't do an experiment, we can use the following criteria to still establish that causation. Is the association strong? So going back to smoking and lung cancer, there's been a strong association between asking people how much they've smoked and then how long they have lived. Even though that's not an experiment, there's a strong association there. Is the association consistent? For many, many years, studies have shown that people that have smoked don't live as long. The larger of the explanatory variable are associated with stronger responses. The alleged cause precedes the effect in time. And is the alleged cause plausible? I think it's pretty plausible that if you inhale smoke on a regular basis for many, 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 many years, it's probably not healthy and you won't live as long. When you are doing research at the university level, there's many different avenues that you can take in order to do the research that you're going to do, but you usually have to go through a review board to make sure that there's no ethics that are being violated. And you need to have informed consent of the individuals involved. When I was getting my master's and doing an action research project, if I ever had to use students, I had to get the students and parents' permission. I had to get the university's permission. And this is all to maintain a code of ethics for the research, which is very important. And that'll do it for section 4.3. We'll see you in class.